my talk is going to be about an introduction to problem setting. So in contrast to Frederick's talk that was objectively correct, everything he said makes sense, it's about standards. This will be a very opinionated talk in that a lot of things I'm going to say, these are good things that are you having good problems and stuff like that. So this talk is mostly going to focus on the principles of what you should do. But if you then feel very inspired from all of these ideas, then stick around, because after me, Rasmus will have a talk on how to actually implement these in the problem package format that Frederick talked about. Okay, so let's get started. So my name is Joshua Andersson, and this is, okay, closer, okay. Yeah, and this is an introduction to problem setting. So I guess first off, I mean, what even is problem setting? It's not a word in a dictionary, right? So I personally would guess that it's from, yeah, a problem set, a set of problems, what you do in a contest. So maybe the act of creating a contest, I don't know. I'm just going to define it basically inventing, implementing, and like selecting problems, the whole thing basically. So then why do I do all of this? I'm gonna try and sell you a little. So first off, it's very fun. You get to be very creative, you get to, you know, have your problems in contests, discuss them with participants, exchange ideas. You also get to engage with the community. If you can create good problems, you get invited to different places. That's always fun. And I guess finally, it's very educational. You improve your thinking, obviously, blah, blah, blah. But one of the hidden benefits is that you become a good judge also. And that gives you very good intuition for when you could choose a problem and when you can't. Secret tips from the coach. Okay, so I guess maybe I should convince you that given all of these opinionated opinions, that I'm not just some hobo. So I've been the head judge for the Swedish IY selection for 2 years. So that's like both come up with ideas, selecting which problems are good, which are not. I've solved over 2,000 problems, not a lot in the grand scheme of things, but I've seen both good problems and very bad problems, so I know what not to do. I've created over 80 problems, I have modified lots of them, blah, blah, blah. And I think I think I generally have pretty agreeable opinions. Maybe not to very old people if you have old opinions on competitive programming, but the newer generation I think will agree. Okay, so what is this talk going to be about? So basically it will be, okay, how do we invent problems? How do we go about implementing them? And then how do we actually create a contest set? So first off, I mean, if we want to be able to invent problems that are good, we kind of need to see, okay, what even is a good problem? And here we have the extremely large subjectivity. So I've talked to a lot of people, like contestants, and I think the most, it's very productive to make the split between the contestants that are very experienced versus not, because they seem to have very different answers. So if you, for a weaker contestant, it turns out that just being able to like actually solve the problem without any friction is very important. So for example, one of them is that, okay, are they able to understand the statement? Did they understand the problem correctly? And then also it seems that for them it's kind of important that it's fun and also, I don't know, kind of real world. I don't know why you would want that, but for them it seems to kind of matter that they have some feeling that this will generalize. And then another interesting thing is that, you know, standard problems are usually considered bad, but when I talk to weaker contestants, they're usually just happy to be able to apply the knowledge that they have studied. So it might actually be a good thing to have a little bit more standard problems. And especially so to not try to overuse like anti-large language model problems, because those will usually be a bit weird and they feel like, no, this isn't what I practiced for. And I guess then also reducing possible friction, like don't force them to do like a precise floating point calculation, don't force them to use fast input, avoid like edge cases probably. So I think the main takeaway for like weaker contestants is that just give them a nice problem where they can read it, understand it, then think a little, code it without hopefully too many issues, and then get AC. That should be kind of the goal for a weak contestant. Then, so interestingly, for stronger contestants, they're kind of more resilient to annoying things like floating points, etc. And from what I've found, most of them usually value that the problem should bring some new idea. It shouldn't just be, oh, think for 5 minutes reduces to a standard algorithm. Instead, it should be maybe you just think for an hour, and then you can just code using standard stuff like maps, etc. Or it could be that you use existing data structure algorithm in a very novel way, or even like invent a new data structure if it's novel enough. And then I guess the problem should be quote unquote beautiful, which is hard to define. One person said that to them being beautiful is that you think for the problem for a long time, and then you get just like, it seems very hard, but then you get one idea and it kind of unlocks the whole problem, and from there it's easy. For them, that feeling is amazing. And another one really valued having the problem be lots of small steps, that you go through multiple insights, like putting out a puzzle almost. But I mean, when you have experience, if you have done a lot of problems, you just know, yeah, this was a nice problem. But it's also very important that the problem is quote unquote competitive. So in the sense that it should not have appeared before. You shouldn't just be able to solve it instantly because you have solved lots of problems. You shouldn't be able to Google it if it's like an online contest. You should not be able to paste the sample into the online encyclopedia of integer sequences and just find a formula that solves the problem, which actually does happen in Codeforces from time to time, which is bizarre to me. And in general, most people dislike if the problem is cheesable by some weird heuristic backtracking or bit set or stuff like that. So avoid that if possible. But apart from there, it's a lot more subjective. So some value that you think for like an hour and then the implementation is super short. Other want to use their extensive data structure knowledge. Other like the implementation challenges in ICPC. So I say that one of the big takeaways here is that apart from like being beautiful, you should just know your audience. So if you're making a problem for a specific contest, look at what has appeared previously, talk to like alumni from the contest, figure out what do they value. And that should also be a very good guiding point. Okay, so basically for weaker contestants, the important point is basically that reduce the friction of it being a programming contest, just let them focus on thinking and then like implementing. And then for stronger contestants, I would say overall, just have a original problem that isn't just like spamming standard techniques. But also one interesting note on that is that standard to who? So this is also the know your audience. So if you are setting a contest for 1800 rated on Codeforces people, then you know a technique that might be standard for 3000 rated people, that doesn't matter. So it's your degree of well-known. Okay, so with this in mind, let's see now how do we invent problems. And the funny thing is that I think the best way of doing it is also kind of the most obvious one, which is that you just think of an original problem, maybe sort from an everyday situation, and you try to solve it. Usually, this won't give a good result instantly. Either it will be too easy, unsolvable, maybe even boring. But then what you do is you take the initial idea, tweak it in ways, and then see, can I make this interesting? And usually, this is very time consuming in that you don't know, like you might try to solve a problem for 5 hours and not succeed, and you still don't know if it's solvable or not. And there's no way of knowing if a problem will be interesting before you have solved it. But also doing it in this way usually yields the more novel problems, like more interesting solution ideas and more natural problems, kind of. Then we have kind of the method that newer problem setters will use to mass produce bad problems, which is just take some cool solution idea / insight, etc., and then try to work backwards to see what problem could be solved using this. And the nice thing about this is that if you have some good algorithm or solution or data structure, you'll be able to, like in an hour, probably create a problem. So it's better if it's on demand, But there are some drawbacks. So first off, the problem usually feels artificial a little. And in addition, there's also the risk that the problem you actually find, that there is another solution that is easier than the one you presented. And of course, it's not going to be as novel. And then a variation of the same method, instead of taking an idea, you just steal an old problem, like sufficiently old from an old contest or an exercise like in a course book or a paper, and then you modify it. And if you manage to modify it sufficiently, you might actually like bring a new idea to the table, but the risk is that experienced participants might have already seen it and get a free solve, and that's suboptimal. Okay, so these are kind of the like big methods in my opinion, but then now I have lots of stranger, smaller methods. So this is one of my favorites. You misread a problem statement and then you spend 1 hour solving the wrong problem, which is not a good contest strategy. But sometimes it turns out that the misread problem is actually very interesting. So if you know that the people who have done the contest you just did won't be like competing in the contest you're submitting to, then it might not be a bad idea to just submit that. Then another one, just go on a problem archive, read problem names and try to guess what the problem is about. The main drawback with this one is that you might come up with the exact same problem that they did, which has happened to me. I should stop laughing right into the mic. That's probably not nice. Then another one, kind of hacky, but might yield better results. Start with a problem that is NP, or where like O of n squared is the best known time complexity, and just throw in a random constraint and see if that makes it solvable in like n log n or polynomial time for NP problems. Then random ways to look for inspiration, just go on Google Maps, zoom into somewhere and see how can this be a problem. Just look at a random image, have like a big list of like different keywords, take random combinations of these, just get your gears turning somehow. And then you also pick up a lot of tricks along the way. So one of my favorite ones is that suppose you're like preparing a problem, but then you kind of realize along the way that it's more interesting to generate test data than to actually solve the problem. So then why not let the contestants generate test data? So the problem is about like generating input to the problem. And then if you want to be very funny, you could do both of them. So you have both like solve the problem and generate input in the same contest, or like both solve the problem and write the checker. So just, you will pick up like different small tricks like that along the way to fiddle around with problems. Then just general tips. Write down all your ideas in a central place. I personally use a secret Discord server because you very easily forget stuff, and even the bad problems can be good. If you just go, one of my ways I like to like invent new problems is just look at like old rejected problems and see if I can turn them around in some way. And usually if I just go and scroll on my Discord for like 30 minutes, I will be able to come up with a new problem. Then in general, keep your mind sharp. I personally notice that when I sleep well and I'm not stressed, I am better at inventing new problems. And then also expose yourself to new ideas, read lots of high quality problems like the Word Finals where we are now. But personally, I think that some of the most innovative problem sources are high school Olympiads. So like the IOI, BOI, COI, JOI, because they are usually always innovating kind of. And also, if you can't solve a problem idea you have, but you have a strong feeling that it can be, then maybe ask someone for help. But you also shouldn't overdo it, because then they might start ignoring you. Practical experience, unfortunately. Okay, so these are my tips for how to invent a problem. So let's say now that you have a great problem idea, how do we actually implement it? So I'm not going to specify that exactly. There are lots of good tools, but I'm going to talk in general terms that apply to all of them. And if you want a more specific one, stick around for Rasmus' talk. So I would say that, I mean, one of the most important things is that just the statement is good. And now, in my opinion, the utmost importance of a statement is that the problem is communicated clearly. And that should take priority over everything else, even good flavor. It's not a good idea to force flavor if it reduces the understandability of a statement. Make sure to always define unknown terms, what even is a cactus graph, morphism, I don't know. Use correct grammar, common and precise phrases, like people who don't have English as their first language should be able to still understand it, and LLMs are very good spell checkers, don't have too much pride, actually do use them. You should also describe all constraints. One of my most favorite pet peeves in the Kattis archive is when I see a problem for like 2010, and they don't specify the number of test cases. So in theory, like a 1 terabyte input file is valid, and I would just get TLE from reading input. So please write down the constraints so we know if the problem is solvable. And then good to have, always have samples, preferably with explanations, even if they seem obvious to you. Illustrations are always relevant, so use maybe GraphViz for graphs, ticks if you want more control. And don't tell anyone that I told you this, but Google Slides are actually pretty good, even if they are a little budget. And if possible, have a fun story. Sometimes you can even make the statement clearer. Then, so the way you usually do it is that to generate the data, you write a program that generates a lot of input, and then you write a judge solution that is run on every input to generate a corresponding right answer file. And above all, this must be correct. Otherwise, you have messed up terribly, and there is no good fix for it. Because even if you rejudge, contestants have lost time, etc. So I personally like to actually start with the slowest possible solution that I can think of, that I know is correct, and then I improve the complexity like iteratively. And then I end up with like 2 to 4 solutions, and I can just like run them on multiple inputs and ensure that they all get the same output. This catches a lot of errors, but not all of them. Then just in general, write carefully, try to anticipate the kind of errors you might face. Int overflow, float, be especially scared of floats, and just edge cases in general. If there are parts of the problem that you're unsure of, prove correctness, ask a mathematician friend if you can't do it yourself. They are unusually willing to help. Or what did I just say? Yeah, anyway. They usually want to help. And then also make sure that the problem is solved by at least 2 different judges. Because otherwise you might end up with a situation where your solution is solving a different problem that's what's described by the statement. And this way you can double check it, and also you find more solution approaches, which is useful for the test data. So above all, test data should be correct. That is to say, it should follow the input format specified in the statement and respect all constraints. So you should write some program that reads the data, checks the format, and then checks all the constraints given in the statement. And make sure to actually sync the code of the statement and the checker program so you don't have a mismatch, because then it's pointless. Then how do you create strong test data? Well, I mean, common sense, first of all, try to find multiple ways to solve the problem, and then kill all of them that shouldn't work. Very stupid advice, but just I need to check it. Actually go look in the input and answer files. Is it what you expect? There have been instances where I found that every single answer file had the same value, which I don't think was very intended. Visualize it. It's just good to sanity check. Then here is a very strange tip. Ask an LLM to solve your problem using greedy, even if greedy is not the intended solution. Because if you iterate enough, usually, or like at least 30% of the time, it will find a solution, a super weird greedy. And then now you have something to actually kill and create like more strong test cases for. And just try in general to anticipate ways in which you might be able to quote unquote cheese the problem, like solve it in unintended ways. Think a lot about this. And then even if you do all the past 3 things correct, if you don't set a good reasonable time limit, then it will all be for nothing. So, I mean, a general rule of thumb, allow a margin of 2 times the slowest judge solution, and don't write a too fast judge solution. Avoid using SIMD in it, avoid using super fast input. Do not go onto library checker, copy paste the fastest solution to a sub-problem and use that, and then have the time limit be 1.5 times that. That has happened in a contest, and needless to say, people didn't solve it. They got the right complexity, but not the constant factor. So in general, be as generous as possible, while still being confident that you kill all unintended solutions, so that people don't have to worry about the constant factor too much. and then write judge solutions for all allowed languages, I would say in theory, but then Kattis has like 40, so we usually suffice with like C++ and Python. Okay, so that were my thoughts about how to implement the problem. But let's say now you have been tasked with that you have gotten a lot of problems, and now you have to assemble them into a contest. So what makes a good problem set? So this is probably my weaker area because I have not done that many contests compared to problems. But I would say one of the most important things again is know your audience. So what is a good problem in one contest is probably a bad one in another. So make sure that the difficulty is appropriate, that the techniques are reasonable for the contestants to know, and in general, maybe you shouldn't have a computational geometry problem in IY, but maybe you have it in ICPC World Finals, or vice versa. And then try to make the problem set overall enjoyable for both strong and weak contestants. So the things I talked about earlier, make sure that the easy problems are very approachable and you don't get stuck bogged down in details. And the hard problems should be interesting. And also just to make the difficulty curve smoother, it's usually very easy to just add more easy problems because strong teams will breeze through them, but it will give more fodder for the weaker teams to actually do stuff. And then in general, try to cover a broad set of techniques. Different teams are good at different things, and they should all have a chance to excel. So don't have 5 math problems, don't only have 5 DP problems, have a broad topic. But also don't add diversity at the cost of quality. Suppose you have the choice between adding a second DP problem that is very good or another problem from another topic that is bad, then take the DP problem, obviously. Then the third, that's maybe questionable, but you know. And a little more, so personally, my rule of thumb is that imagine that every team, like keeping a good difficulty curve with problems, that every team should be like 1 to 2 hours away from solving a new problem. And then I try to imagine hypothetical teams. But then in practice, you might just have the problems you have, so it might be hard to smoothen it out. And then, I mean, the mantra, I think you've all heard of this, no team should solve everything, but every problem should be solved by someone. And the way you achieve the second thing is by having a diverse set of topics, so that teams who are very good in something get to solve their specialty. And then, so let's say that now you're very inspired by this. Where do you actually begin if you have not done any problem setting before? So doing problem setting is actually a very communal thing, that because contests are run by people, it takes more, it's not sufficient to just like create problems. You actually need to like advertise, maybe you need a contest platform, blah, blah, blah. So there's a huge community around it, get involved with the community. And then I would say start with the easiest one with lowest bar to entry, so maybe your local IY community or the national ICPC contest. Because there the quality standard will most likely be the lowest, and it's easiest to get the problems accepted. Yep. Sorry. Or if that doesn't work for you, then maybe you should just hold a contest for your local university or high school. You can always do that. I did that, and it was fun, although I only got 5 people. So maybe, yeah. And then, you know, learn some contest preparation system. It depends honestly on what they actually use in your region. So if you're in Sweden, learn Kattis. If you're Russia, probably problem tools. If you're in Italy, CMS, I don't know. And yeah, do submit some problems and get in touch with people. And yeah, so that was my list of opinions that I think are good, but who knows in the grand scheme of things. So are there any questions to this?
Yeah, thank you for the presentation. Just one quick question, short question about your, you mentioned on the verification of test cases, you mentioned sing these. If you go back to the slides, if you can. So yeah, I think like whenever I'm creating contests, I have like some checklists basically that I run just before the contest, make sure that if I change some problems, I don't invalidate my checklists and so on. So I run up pretty late just before the contest. And one of the things that I do is basically checking whether my verifier, test case verifier aligns with the problem statement. But I think in your slide you mentioned sing now, sing these or something like that. So like I'm wondering whether there's like a problem preparation framework out there that actually does this automatically, because like usually these two numbers, one of them is in code, like the verifier is a code, and the one in problem statement is like a latex or something, so it's usually like hard to verify that it's the same. Yeah, there you go. That's sync this. So like, is this like a automated sync? Like, do you have automated sync on this?
So currently I do not do that, so I manually sync them always, but Katis in the new format will have a thing called constants, where you can define like package level constants. And then you just like write 2 curly braces and a constant name, and it will be replaced in there. So that way you can do it quite easily. Yeah.
Hi, thank you so much for the talk. I had a question about writing problems for weaker contestants. Those of us who are experienced or strong, I am maybe the former, I'm definitely not the latter, estimate the difficulty of problems, I think, in a quite different way to how novices estimate the difficulty of problems. Do you have any advice for setting problems and accurately estimating how your contestants will see them when, yeah, they have a different background than you?
That's a very good question. So I think, at least in Sweden, one way we do it is that we make sure that so we constantly have people who graduate, so we make sure to like collect people, and then we always have a couple of green judges around. So then we can kind of ask them what do they think, or even like ask people to test solve it. And that usually gives you a very accurate estimate. But yeah, I think just like talking to people and making sure to like get multiple opinions is usually the best way.
Hi, a couple of questions for you. You mentioned one thing that I've done before in other contests, where effectively, although the problems were phrased independently and could operate independently, you could use, for example, the output of one to generate test cases for another, even though the problem descriptions inherently weren't like that, but when you actually started digging down into it, that's where you ended up. And that was I thought that was an interesting approach. I think you mentioned something similar to that you've done things like that before. As far as how to get started, the other thing you could do, particularly since we're in an ICPC organization, reach out to the RCD for your region, or reach out to the RCD for a region that you're potentially interested in contributing to, and they can put you in contact with whoever's running the judging program there. And I have seen hardly anybody who had refused, somebody who's ready, willing, and able to contribute. And don't think you have to necessarily be yourself a World Finals medalist in order to do it. At least in my experience, you have to be good, but you grow as being a developer, a problem setter as well, or judge as well over time. So just a few thoughts to add to that.
Yeah, definitely I agree. So I didn't even get to the IOI, and now I'm the head judge running things. You don't need to be the best, you just need to be pretty good and then have some other skills also. Did Christian have do we have time for questions by Christian?
No? Yeah, there you go. Cool. So, yeah, I mean, my quick question here is, I don't think it was actually covered in the slide. Yeah. Sorry. Okay. So, closer. Yeah. So my real question is, IOI, ICPC, I'm sure they run differently in some sense. the timing of when you get things done, I think that there is a bit of a disagreement amongst the people. 1 week versus 1 month versus half a year. Can you comment on what are the different steps that are involved? For example, collecting the problem sets to, for example, other steps that are involved while you make the problem set. So you talked about it, getting 2 solutions that are different languages and different people, and preparing the data, making it stronger, proofreading the problem statement, etc. Like, do you have a sense of how different the timing of those things are between ICPC and IOI? It might be that it's different amongst regions and so on. Yeah.
So I actually don't have a lot of context towards ICPC because I'm a competitor there, and I'm therefore, I'm not a judge. But I get the impression that usually it will be at least around like 3 months or something for NWork and NCPC kind of deal. So for Sweden, so that's one of my weaknesses, that I'm very good at doing stuff last minute. And and almost the worst part is that we are bloody efficient at getting stuff done. So let's say, we usually have like a problem back where we constantly collect problems over the year, but if need be, I think like the shortest contest we have ever done is that we, like in 1 or 2 days, like stole 4 problems from another country, because that's what you need to do for the IOI selection. But then if it's like an original problem with like an original contest with 7 problems, I'd give it like maybe 3 weeks, I'd say, to feel comfortable.
Right. I think that the one thing I'm trying to highlight here is that there's a lack of consensus really amongst the regions, amongst countries, amongst the various different super regionals, divisions, etc. But is it better to have the structure, or is it actually better to not have the structure? What do you think?
I think it depends a lot on the people. So I think if you are able to have a very good structure that people follow, like, okay, we have like a common timeline for all problems, now we're doing this, blah, 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 then probably yes. And I think also in ICPC, the judges are older, so they're better at following such stuff. But I think for us, what works very well is that now we have, okay, how do the contest is in 4 days, please write a judge solution. And then everyone is stressed, so people actually do stuff. So in that sense, I don't know if like we started earlier, if we would be more efficient. And I think that's kind of the youth speaking probably. But obviously it would probably be better to start earlier. I think it's just the kind of that we are still young. So yeah, and it seems that there are no more questions. So thank you for listening.